Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 2 of weekly contest 488, merge adjacent equal elements. So in this problem you are given an integer array nums. You must repeatedly apply the following merge operations until no more changes can be made. So if any two adjacent elements are equal, then we have to choose the leftmost such adjacent pair in the current array and replace them with a single element equal to their sum. After each merge operation, the array size decreases by 1. We have to repeat the process on the updated array until no more changes can be made. We have to return the final array after all possible merge operations. And these are the constants. Nums.length from 1 to 10 to the power 5 and nums of I values also from 1 to 10 to the power 5. So here if you see this example 1, so first this element, right, I have to add. Let's say I have added it. Next time I move to this element, let's say I add it. Next time when I'm planning to add this element, when I reach to this element, I see that both are same. So if both are same, so we have to remove and we have to add the sum. So here let's say I have added sum 2. Then next time I reach here, I see this is 2 and here also previous I see 2. So now I have to just do the summation of these two and I will add 4. So this is going to be your output. Clear this part? So from this thing itself, if you see, I am moving like this. So one thing comes to my mind, let's use stack. So how stack is going to help in this case? So let's say this is your stack. So in this, it's empty right now. Just add the first element 3. Next time when you are going reaching here, when you are planning to add this element, you see the topmost element is not 1, so you are good to add it. You have added it. Next time when you reach here, you see the current element is 1 and at the top of this element you have 1. So in this case what you will do, you are just going to remove this element and you have to add this element to the current. So current element is 1 as of now, and in the top of stack it was 1. So in the current element first you remove it and in the current element just add it, so you are going to get 2. Now again you check if this current element is equal to the topmost element of the stack. No, so feel free to add it. This is done. Next time when you are moving here to this 2, so now you are going to check current element is 2 and the topmost element of stack is 2, then in that case remove it and add it to current element, so you are going to get 4. Now check if current element is equal to the topmost element of stack. No, add it. Now in the end loop ends. So in the end what you need to do, just convert this to a array or list, whatever you want. So 3 4 is the output. That's it. So very easy. Here if you see, initially you are here, array is empty, just add a 2. Now you are reaching here, current element is 2, topmost you see it's 2, so you are going to remove it and add it to current element, you are going to get 4. So now there is no topmost element, just feel free to add 4 here. Done. This is done. Now you reach here, so current element is 4, topmost element is also 4, remove it, add it to this current element, you are going to get 8. 8 is not here, both are not matching, just feel free to add 8 here. In the end just return it. That's it. That's it. So very easy, we just need to do the stack. Okay, and here instead of stack, actually I'm going to write the code using dequeue here. Why? So stack is an old class which extends vector and it is synchronized, and it was designed in Java 1.0, so extra overhead and slower in single thread problems like Leetcode. So this is how you can write the code using stack also. It will also work fine, but dequeue is the modern replacement of this stack. So dequeue should be used in preference to stack. So Java's own docs say this on documentation. Okay, so how we use dequeue? So dequeue, same code, instead of stack just write dequeue here, and here instead of stack just write array dequeue. So it is faster because there is no synchronization, right? And its cleaner API and designed exactly for stack view behavior. So what is the difference between DQ and stack? So DQ you write it like this, and stack you write it like this. And in this we have, for push we have method like add last. Here we have push to peak, here we have peak, and here in DQ we have peak last. To pop we have just pop, here we have poll last in DQ. So this is the only change. If you want to write the code in stack, that is also fine, you can just use these things, and that's it. So in DQ I'm using these things. So stacks work functionality, but functionally stacks will work, but since it's synchronous and legacy, DQ with array DQ is preferred for better performance and cleaner design. So this is just a bonus. Okay, now let's see the code. So here I'm just using DQ. I'm iterating over all the elements in nums one by one. I'm taking the current element, and we have to merge while the top is equal. So while stack is not empty, and then stack dot peak last is equal to cur. So in the cur, I'm just going to add the last element of the stack until my stack is not empty and the peak element is matching with the cur. Done. And in the here, I'm just going to add the element to the stack. And in the end, we have to just since we have to return the list, and inside list we have long now. So here in DQ also I'm taking long, and here I will just simply say return new array list, and I'm just going to pass this stack here. That's it. So this is your code, right? So what is going to be time complexity? So time complexity, you can simply say, oh, it's going to be of n only. Mostly here we are just doing the merge, but mostly we are iterating over all the elements just once, right? So I hope that you guys are able to understand today's problem, this question number 2 of weekly contest 488. And if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys next video. Thank you. Bye bye.